Now, let's try and use inequalities in a linear equation and try and write the answer as an interval in interval notation. A linear inequality is an inequality that only contains linear terms. We can think of it as a linear equation where the equal sign is replaced with one of less than, greater than, less than or equal to, or greater than or equal to. But there are no squared terms or rational function terms in it. In order to solve a linear inequality, we do the same steps that we do when solving linear equations, but there's one key difference, is anytime we're multiplying or dividing the entire equation or the entire inequality by a negative number, we have to flip the direction of the inequality. So that means less thans become greater thans become less thans, greater than or equal to become less than or equal to, and vice versa. Let's give it a shot. Let's solve the following linear inequality. We're going to solve 3x plus 7 is less than or equal to 5x minus 6 by looking at the values of x that cause this to be true. Algebraically, the steps are the same as if we were solving the equation 3x plus 7 equals 5x minus 6, in which we would collect our like terms. We would want all the x's on one side, all the numbers on the other. So let's go ahead and subtract 5x from both sides. And if we want, let's also subtract 7 from both sides. That gives us 3x minus 5x is less than or equal to negative 6 minus 7, or minus 2x is less than or equal to minus 13. In order to solve for x, we want to divide both sides by negative 2. But in doing so, we have to flip the direction of our inequality. After simplifying, that gives us x is greater than or equal to 13 over 2. If we wanted to write that as an interval, we could start with 13 over 2. And we'll notice that since we're greater than or equal to, we will make this a square bracket. Since there's no upper bound here, we're going all the way up to infinity. Why do we flip the direction of the inequality? Well, you can try it for yourself. Pick some number x that's bigger than 13 over 2, say 7, and plug it in to the original inequality. See if it's true. Take some number less than 13 over 2, say 6, plug it in, and you'll see that it's no longer true. Try it yourself. Let's do one more example, where this time we have to do a bit of algebra before solving our linear inequality. This time it says 3 times x minus 2 is greater than 10 minus 5x. As usual when solving linear equations, we need to expand the parentheses first, giving us 3x minus 2 is greater than 10 minus 5x. As before, we'll add 5x to both sides, and while we're at it, we can add 2 to both sides. That gives us 3x plus 5x is greater than 10 plus 2, or 8x is greater than 12. As before, we're going to divide both sides. This time we're dividing by a positive number, and so we don't need to do anything different. We can just write x is greater than 12/8, or x is greater than 3 over 2, 1.5. As usual, we can go ahead and write our interval. X is bigger than 3 over 2, so that means we start at 3 over 2. And since it's not greater than or equal to, 3 over 2 is not part of our interval. Round parentheses. We're going up to infinity, which always gets around parentheses, and that's how we write the solution to this linear inequality in interval notation.